Hi guys, welcome to the first lesson here today for the first day of the new packet. Again, you can print it out if you have a printer. If not, it's perfectly fine to just work off of paper. It's pretty much going to be all that we're going to be finding surface area and volume of shapes. But the first part of the packet, the first couple days, is kind of some background information and getting on the same page with as far as classifying two-dimensional shapes and also being able to get you to some notation that you'll see using geometry with these drawings. So like today's homework is going to be drawing two-dimensional shapes, but it's not about actually making the shape correct. It's more important that we label using the labels that I'm going to be showing you here. All right. So today, and on the packet, I was nice and I gave you the notes already filled out. In case there's anybody that doesn't have access to online stuff, and I left the packets at the school for them. The notes are already filled out for them, but it's certainly easier to understand with explanation, I think. At least that's the feedback I've been getting from students. So let's go ahead and take a look at page 2. Page 2 is sideways. Basically, this is what I call a family tree of quadrilaterals. So they kind of broken into two main families here, the trapezoid family and the parallelogram family. And you classify those two families where the trapezoid family here will be the one we focus on first, where it's just one pair of opposite sides parallel. Now, the way I wrote all these trapezoids, I did it so that the top and the bottom was the one pair of parallel sides. So it's a pair, top and bottom, one pair. And the top is parallel to the bottom, the top is parallel to the bottom, the top is parallel to the bottom. Notice that there's absolutely nothing wrong where you could write these things upside down or sideways. Like for example, if I happen to draw one like this, the left and the right are parallel, that's still considered a trapezoid. It's just turned sideways from these ones. Note too that you'll sometimes see, I've seen different way these are written. Sometimes you'll see arrows to indicate that sides are parallel. I'm not going to use that notation much because most of the things I've seen recently, they haven't been using that notation as much. So we're going to stick with the notation that you see in your notes here. So this is a regular old trapezoid. 4 sides, these are all quadrilaterals, that means 4 sides. And the only thing special about it is that the top is parallel to the bottom. Boom, trapezoid. These sides are not the same length, which we could say congruent if they're the same length. None of the angles are necessarily the same, and these sides are not necessarily the same. Now what you'll end up saying here when you classify special types of trapezoids, we call it a family tree. They kind of inherit the traits of the things that are above it. So it's going to still be 4 sides with an opposite pair, 2 opposite sides, or 1 pair of parallel sides. But if we have more special characteristics, we can call them a special type of trapezoid. So one of them is a right trapezoid, and a right trapezoid is simply a trapezoid where 2 of the angles are 90 degrees. In this case, it means that like this side right here, you have a 90 degree and a 90 degree there. Notice that it's a little square box in a corner to note that an angle is 90 degrees. Another special type of trapezoid would be called an isosceles trapezoid. An isosceles trapezoid has 2 sides that are the same, and you know that these are the same because we put one dash mark or tick mark on each one of these sides. So that's saying that this side is the same length as that side. Those 2 sides are congruent, they call it. Also, you'll see these little arcs here in the corners, and what that's telling me is that these 2 bottom base angles are the same. And also, these have 2 arcs in these ones, so that's telling you these 2 upper base angles are the same. So in other words, if like this angle was 30 degrees, that one would be 30 degrees. If this angle was, let's say, like 150 degrees, that one would be 150 degrees. Okay? So an isosceles trapezoid has 2, they call them the legs of the trapezoid are the same, and then they have 2 pairs of base angles that are the same or congruent. So these bottom base angles and these top ones. So that's the trapezoid family tree. And again, if we're normally in class, I'd have you draw all these in, but Mr. Hardenstein, being the super swell, nice guy that he is, I already have them drawn out for you. The other kind of main family we call the parallelogram family. Okay, And on this one, it's both pairs of opposite sides are parallel for all the parallelogram family, hence the name parallelogram. It has parallel right in it. So all of these are actually types of parallelograms here. The parallelogram, all right, is got a few extra characteristics to it. It's a little bit different than the other ones. A parallelogram, not only are like in this case the left and the right parallel, they're also congruent. You notice they each have one mark, so that means that those two sides are the same length. The top and bottom are parallel. They are also congruent. There's 2 marks here and 2 marks there, so it's telling you that the top and the bottom are the same length. All parallelograms also have opposite angles that are congruent. So this angle and the one opposite both have one arc in it, so that's telling you that those 2 angles are the same measure. And these 2 have 2 arcs in it, so that's telling you that those are congruent. So everything below this is going to have all those traits plus more. So the rhombus and a rectangle and a square, those are all special types of parallelogram. And a rhombus and a rectangle kind of have, they just deal with the side lengths or the rectangle. Or the angles. I said rectangle, I meant angles there. So for example, a rhombus is a parallelogram where not only are the opposite sides congruent, all of the sides are congruent. So this side, this side, this side, they're all the same length. So if this bottom is 9 centimeters, that's 9 centimeters, that's 9 centimeters, that's 9 centimeters. The angles, opposite angles are still the same, just like before. So this is kind of like, a parallelogram is almost like if you took a rectangle and kind of smushed it to the side. And a rhombus is almost like a square that you smush to the side with it. All right, so it inherits everything from here, but it's got extra, and the extra thing is that it basically, a rhombus is a parallelogram with all the sides equal. Well, a rectangle is a parallelogram where all the angles are equal. And it turns out not only are they all equal, they all end up being 90 degrees. So 90, 90, 90, 90, 90. Notice the boxes there. The opposite sides are still parallel, but they're not they're not all the same length. The opposite sides are congruent. The top and the bottom opposite sides are congruent. But notice, not like the rhombus. This one, basically, like I said, all the sides are equal in a rhombus. All the angles are equal in a rectangle. And then a square, finally, is the perfect one. It inherits everything that's above it. So it's a parallelogram and a rhombus and a rectangle. So it means everything's got to be, opposite sides are parallel because of a parallelogram. All the sides have to be equal because it's a type of rhombus. And all the angles have to be equal because it's a type of rectangle. So square is like the perfect quadrilateral. 4 sides, all 4 sides are the same. 4 angles, all angles are the same. They're all 90 degrees. Okay? So when you're drawing on page 3, drawing these shapes to get used to drawing them, it's not as important that you have it perfectly. Like you'll notice here, if you actually measured my square, I did not actually make this the exact same length as those. This is a sketch. And this is the way it goes in geometry. Your drawings don't have to be exactly perfect. They have to be labeled perfectly or labeled correctly. And basically the label says, yeah, I know they might not be exactly the same, but because I put 1 mark here and I put 1 mark there, yeah, they are the same. They're saying that all 4 sides are the same length. And that's how you accurately do a sketch in math class. So, if there's anything you need explained better, you can type in a question to me on the comment section of this post, or go back and watch the video again to see if you can re-see where I explained it. The work I want you to try for tonight is page 3. It's drawing the shapes and labeling them. They all say draw and label. Okay, so you can go back and look at what we did on page 2, or you can try to challenge yourself and see if you can do it on your own. So maybe I do the very last one. We'll draw a rhombus. I'll do this one together. Okay, rhombus is a type of parallelogram, and it was a special one where all the sides are the same. So if I draw a rhombus, and again, it doesn't have to be perfect, but my sketch is going to be perfect because my labels will be accurate. So I'm going to do the best I can to try to draw this the right way. You can see I already messed up a little bit. And the angles aren't right. So by itself, that's not a very good rhombus drawing. It kind of looks similar to it. But as soon as I say that this angle and this angle are the same, and that this angle and this angle are the same, it now is going to be at least a parallelogram. And if now I go ahead and say all four sides are the same length by those marks, now this thing would definitely be what we would call a rhombus. Opposite sides, I'm sorry, opposite angles are congruent, and all four sides are congruent. That's a rhombus. Okay, so try the other 5 on page 3. It shouldn't take you very long. I'll go over the answers tomorrow, and then we'll move on to the next page notes the day after that. So have a good day. I hope everybody is enjoying their week, and I will check in with you guys soon. It was nice to talk to some of the people on the Google meeting yesterday. We got about 6 or 7 kids total throughout the day that I got to talk to, so I'll post that again. Most people said that they enjoyed doing it. They just wish more of their friends were there. It's not like it's mostly a chance for everybody just to catch up and get you guys to hang out a little bit, because I know everybody misses their friends. So trying to give you an opportunity to do that with the Google Meet. So I'll do that again next week for everyone. 9th period, I'm going to do it Friday, and I'll put a post on what time we'll do that on Friday. All right, I'll talk to everyone soon. Have a good day.